Hello, everybody. This is Kyle Seitz with Licking County Soil and Water Conservation District, going through your introduction to pollution tolerance index as a metric for macroinvertebrate community health. We will be going over the data form that we use, some of the background on macroinvertebrates and their habitat, and at the end we'll go through a demo of how to assemble your score and how to determine what your pollution tolerance is. So first things first, what are macroinvertebrates? If you're new to the whole water quality world, macroinvertebrates are basically small organisms that are large enough to be seen with the naked eye, that do not have a backbone, and are live either a portion or entirely within the water. Uh, in this case, we see crayfish, insect larvae, leeches, shellfish. Um, all of them are considered macroinvertebrates. Insect larvae spend a vast majority of their time in the water, like mayflies, dragonflies, caddisflies. Crayfish live predominantly in the water as well as leeches and shellfish. So, in order for them to count for our macroinvertebrate sampling, they need to be on that list of organisms. And the insects that emerge from their larva state to their adulthood do not count. So here's a basic look at the data sheet we use, the biological monitoring data sheet. It's got four basic components. We've got the metadata area where you add your time, date, and your information on your watershed, your hook, and whom is doing the monitoring. We've got your sampling method. In this case, it's either kickseine or dipnet, and your habitat sampled. So we have riffle, undercut banks, sediment, leaf packs, snags slash submerged vegetation, and other. Then the bulk of your data will be in the pollution tolerance index portion of the form, which basically um, counts up all the different organisms you find on this list, and each organism counts only once for this form. So you could find 100 caddisflies, but you'll only check caddisfly once, and you'll only get the 4 points corresponding with finding that organism in that tolerance group. Um, we'll go over a little later how you score and use this section, but you can take a look at it here. It's the four groups, the four different scores for each group, and then this is the overall scoring guide. And in additional observations, this is focused in on other organisms that were not macroinvertebrates that you found or that were known as invasives. So if you find native mussels, that one's a very important one to check off, mostly because of their statute or their status as a state and federally endangered species for the vast majority of them. Zebra mussels are an invasive species. Rusty crayfish also are invasive. And then if you find aquatic plants, percent algae cover, and then down here, if you find fish, frogs, other amphibians, any vertebrates that you find in the water, you can include those here. We'll go a little bit deeper into the metadata now. So we have the date of sampling and begin time, end time. Should take 2.5 hours, maybe 3 if you find a lot of organisms. But you put in your in time and your end time. Then you put in how many adults, how many youth were participating with you during this sampling event. Normally, it's 1 or 2 adults, and perhaps some youth if you bring your children out with you. The certified monitor's name will be me, Kyle Seitz. And then the organization name, if you have an organization that you're affiliated with to do these samples, you can add that. Otherwise, it's not really a problem. Um, Then we do watershed name, which would be the HUC code as well as the name. So the HUC unit code on this one says 14. We also use 12. The 12 unit code uh, is the sub watershed that your area resides. So I'll go a little bit more into that later, but we'll provide that information for you if you're not sure. Stream and river name. So if it has a name like Raccoon Creek, South Fork Laking, Brushy Fork, you would include that here. And then you would include your GPS locations for your sampling site. So like I said, if we assign you a site, we will provide you with the HUC-12, the stream name, and the GPS coordinates. Since we'll already have it mapped, and it'll be easier for us to give you those informations to add to your data sheet. If you're sampling on private property, either someone you have an agreement with or your own property, you can give us the GPS points and we can fill you in with the HUC-12 and the stream name. That way you can have the data without having to search through different websites to find it. Also, members that provide GPS locations, either for this site, either for our site or for ones that they're providing, please use decimal degrees. It's a lot easier for us to pin those points in GIS and Google Earth with decimal degrees than it is with degrees, minutes, seconds. So just make sure we standardize those data points. The next section, sampling method and habitat. Uh, your sampling method will either be a kicksain or a dip net. Some of the volunteers have dip nets. Most of them have dip nets. Some of them have kicksains. Just denote which one you're using for this samplings event. And then the habitat, we recommend you do at least 2 habitat types, and prioritize the higher quality habitats like riffles, then undercut banks, then snags and vegetation, then leaf packs, then sediment. I understand some streams may not have all of these different habitat types, so whichever one you see that is the highest on this list here, um, do that one and then one underneath it. So if you have a more sediment um, sediment laden or unconsolidated bottom stream with not very many riffles, you might have to do some undercut banks, some vegetations areas, or just the sediment itself. So that we have the best quality habitat accounted for in the sampling. Obviously, you can do additional if you'd like to, and it will definitely increase your score. Because each organism has its own niche within in the stream. So the more diversity of habitats you check, the more diversity of organisms you're likely to find. And this kind of displays that principle. So you've got your riffles here that could be full of mayflies or caddisflies. You've got your underhanging banks or your logs that could be dragonflies or damselflies. And then you've got your low flow pool area that could have planaria or midges or any sort of other lower lower requirements on water quality. Um, so moving on to the macro pollution tolerance index section. Like I said earlier, there are 4 categories of macroinvertebrates ranging in tolerance from very tolerant to intolerant. These intolerant species are likely to be found in the highest quality habitat types, mostly riffles, sometimes undercut banks, but mostly riffles is where you would find these guys because they need the higher oxygen content. Then you move on to the next area, you find damselflies, dragonflies, crayfish. A lot of these can be found in some of those second tier habitat areas like underhanging banks, submerged vegetation, root wads. and they don't have as high of tol or requirement for oxygen. They still have gills, but they aren't as intolerant of low oxygen levels. And they also require in some cases like the dragonfly and the damselfly to be able to cling to things to hunt. So they need either aquatic plants or root wads or submerged trees in order to cling to. Um, when you're moving down to the fairly tolerant to very intolerant, or very tolerant sections, these guys are far more tolerant of low oxygen. You have planarias, leeches, midges, aquatic worms, left-hand snails. These are they can live in stagnant pools or low oxygen environments pretty readily, and they don't have as much of a requirement as these. So, say you only sampled a riffle and a root wad, you'll likely not find as many of these lower tolerant groups for 3 and 4 as you will the high tolerant or the intolerant species for groups 1 and 2. So keep that in mind when you're sampling. The more habitats you sample, the more diversity you get, and the more likelihood you'll have a higher score. Um, Kind of went over that here, but like I said, it's very related to their dissolved oxygen tolerance. As far as these categories go, more pollution can degrade oxygen levels as well. So if you have a riffle and there's some water quality issues, whether it be nutrient enrichment or something along those lines, you may find lower oxygen based on those contaminants, and you could in turn find less these category 1 organisms in that riffle if the oxygen levels have been depleted for long enough. So that's kind of how these categories break down and in some things you might want to think about when you're sampling. Um, Here's some examples of some of those category 1 organisms. You got your mayfly, your stonefly, caddisflies, hellgrammites, water pennies. Um, these are all high quality or high water quality species or organisms. You can see on the mayfly, it's got all these gills on the side, so it requires a lot of oxygen. Um, then you have your two, the dragonfly, cranefly, and damselfly. Uh, they don't have as much requirement as I've said, and you can see some of these have mouth parts that look like they might be predators. So they're more sight predators, so they can see their prey, grab it, and they don't need the high flow of water to kind of wash away their victims. Um, then you have your category 3, your planarias, and your dipteras, your fly larvae. These are you might recognize something that looks like this. It's like a mosquito larva. They can live in low oxygen levels as they tend to have siphons that help them breathe outside of the water. Then you've got your lowest tier, rat-tailed maggot and left-hand snail. The snail can leave the water. That makes it a lot more intolerant or a lot more tolerant of low oxygen. So scoring. Number of organisms of a certain order doesn't matter as long as you find one, like I said earlier. So you could find 100 caddisflies, but that caddisfly only counts one time on the data form. Um, and after you process total number of groups, check marks per category, multiply by the factor for that category. Example, you find 2 caddisflies, 1 water penny, 1 mayfly nymph, and 1 ripple beetle. Um, and those are all in order 4, the highly intolerant. So you'd have 4 points per organism at 4 points per group in category 1. So 4 times 4 is 16. Um, So given that principle, here's an example of a completed analysis. You've got two mayfly species, three caddisflies, a water penny, two dragonflies, one cranefly, one crayfish, one blackfly larvae, and a left-handed snail. We've already have this filled out. So based on this pollution tolerance index area, what would be the score? Um, I'll give you a couple minutes to fill out the answer, and then we'll take a look. If you're not finished yet, feel free to pause the video and you can continue your calculations. We'll go over the answers now. So you got three organisms in PT group one, so three, and then you multiply it by your weighting factor of four, and you get a 12. You have two organism or three organisms in pollution tolerance group two. You got your crayfish, cranefly, and dragonfly nymph. Three of those times the factor of three equals nine. You've got the black fly larvae in PT group three. So that's one organism, and at a factor of two equals two. And then you have the last one, the left-handed snail, with a factor of one equals one. So you add up these 12, 9, 2, and 1, and you get 24. And that corresponds to an excellent water quality score of 23 or more. Um, so as I said earlier, we've got these groups of pollution tolerance for the narrative section of 0 to 10 for poor water quality, 11 to 16 for fair water quality, and 17 to 22 for good water quality, and then 23 and over is excellent. These generally align with um, the metrics that the Ohio EPA uses to determine what water quality is for macroinvertebrates for their processes, but they are a lot more in depth than ours as they go to species level and they count individual species for each group. Uh, then you go to the other biological indicators section. This is where you would put in any of the other aquatic organisms, the aquatic vertebrates that you might find, whether it be fish, salamanders, frogs, birds, anything you see that's while you're out doing your sampling that you want to include. And this line is more designed for either sensitive species like native mussels or invasive species and algae cover. These are all important information to add, but don't directly affect the scoring. Um, and that will end the presentation today. So if you have any questions or you'd like more information, feel free to reach out to me. Use my email and the mainline number. Otherwise, thanks for watching, and I hope you enjoy your stream team.